Okay, let's start with presentation. We will talk a little bit how we at Feedzai are reshaping quality engineer and some quality practices that we are doing towards following a CI/CD mindset in our development process. As Antoine asked, I will just do a quick introduction about myself. I have more or less 9 years of experience. I work at Feedzai since 2050. Right now, I am leading from the QA chapter transformation project where we aim to reduce the lead and cycle time across our different products at Feedzai. So it's pretty aligned with this CI/CD that we are talking about, and also with quality engineering principles. So I get very, very happy with the invitation from Antoine because it's quite aligned with what we are currently doing at Feedzai. My main interests are test automation, CI/CD, in order to have fast feedback loops to the developer, quality engineering practices, and trying to embrace quality as a whole team approach. As Antoine already said, I am passionate about quality. I like to attend to meetups across Portugal, to deliver talks, also to attend to talks. So it's basically that. And thank you also to Ministry of Testing Leiria for this opportunity. I will talk just also a little bit about Feedzai for the ones that did not know Feedzai. Feedzai is a company where the mission is to keep the commerce safe and ensure that fraudsters around the world are not able to pick your money and basically protect your credit account, your accounts with your banks and etc. You have here some of the customers that we work with in a global scale. Currently, we are around between 500 to 600 employees. We have offices in 4 continents, and also some stats regarding some of the clients that some of the companies that we work with, the transactions that we process in a daily basis, etc. What we do, in fact, just for you to have a briefly understanding. Basically, imagine that you have your credit card that is being used, or it was picked, for example, in some data leak, and there is some person that tries to use your credit card in order to steal money for you. We have a set of components that are part of the Feedzai platform that enable us to understand those fraud patterns and basically try to prevent fraud. So we have a platform that is able to ingest the transactions, the transactions from your bank, and basically with plans, rules, models, data science models, we have then a score that it will be analyzed. We might have two different ways of acting. We might simply prevent the fraud straight away and block the transactions. Or if we have doubts, we might send it to being analyzed in the set of other components that we have, like Feedzai Case Manager, that is done for fraud analysts, that are persons in the bank that try to analyze those transactions and understand if those are fraudulent or not. Genome is also a component from Feedzai that allows fraud analysts to be well suited and understand easily those fraud patterns. So our tech stack is a little bit more complicated. We have other components, but I decided just to showcase those in this small example, just to provide you that this brief introduction. So what will be agenda for today? We'll start initially by talking a little bit about CI/CD and some DevOps concepts. Probably you already know most of them. You might probably work in a company that follows those CI/CD practices, but just for us to create some common ground. Then a little bit about the motivations that we have at Feedzai to follow this transformation project. What are our goals and our focus with this initiative? And then the set of changes that we did from a quality engineering standpoint. Starting by the CI/CD and DevOps concepts. So what is basically CI/CD? I would say that is a mix of three different things. So continuous integration, so ensure that our code changes are automatically tested and integrated into our development flow. Imagine having a developer that creates a merge request and straight away it receives some kind of feedback in a merge request saying if the changes that we made was good or not, if they could be merged into some branch. Continuous deployment, that is basically the capability to put the changes that we are doing in our product into production, and also continuous delivery, so the amount of time where we are able to put those changes into production at different demands. And what is the DevOps part? Basically, the DevOps part is how we are able to integrate the development, so how the features are planned, developed, how the code is built and tested, and then how we put that code into operation, how the artifacts are released and deployed, how the product is operated. Previously, a few years ago, normally those are very separated flows. So there is the development flow and the artifacts that are produced, and then there is a separated team that put things into production. Nowadays, we are starting to see more and more teams that try to merge both flows and have a completely so basically the DevOps is completely integrated. There is no separation between in the different teams. It's only a question of having different roles in the teams, but everyone is able to contribute to the same DevOps flow. What are normally some benefits of CI/CD and DevOps? Those are like personal talks. You might have different opinions, but I think that we are able to reduce the risk of our deployments because we have visibility on regarding the impact of the change that we are doing. We have faster user feedback because once we promote some things into production, we're able to get feedback from our users very fast. We have a sense of when the things start and when they're finished. For example, some feature that we are working on, because the definition of done on CI/CD and with DevOps should be when the feature is put into production. It should not be when the feature is merged into the code base, because you might put the feature in the code base, but if you have some kind of issue in the way that you put the operational part of deploying your stuff, you might simply, the feature is not completed. There is a better team efficiency and cohesion because all the team might contribute into a set of building blocks from test, pipeline, infrastructure, etc. And also standardization, because once you have some kind of CI/CD pipeline that is common to the whole organization and to the different teams, you are able to set a good standards that across those teams. And there are a lot of other ones that we might think of. So it's basically it. Starting a little bit, I don't know if anyone has something that would add to those 5 vectors that I indicated here. If someone wants to contribute with something that is important, if someone's want to jump in and say something.
Mm-hmm.
Okay.
Sure. Yeah, but it's good in introduction. Yeah. I think it's a lot of the trend we see. People talk about dev test, ops, etc. But let's keep simple.
Yeah. Yeah. Okay. So let's then continue. And if you have any kind of question, we might address it also in the end. So what are the main motivations for us to move into this CI/CD transformation project? In fact, at Feedzai, we have some kind of CI and CD practices but those and we have a lot of clients. For example, currently more than 60% of our clients are running hosted on our cloud. Okay, but however, there is we aim to improve the development lifecycle to be more aligned with those state-of-the-art CI, CD, and DevOps practices to ensure that those different profiles like developers, quality engineers, cloud engineers, site reliability engineers, security engineers might work together into this fully integrated flow towards the deployments that we do. And let's see now some pain points that we are trying to address with this initiative. One of them is continuous integration. For example, we have a big number of code repositories at Feedzai from different sets of products and components. Not all of those code repositories have continuous integration completely embedded. We have in some of them there are the continuous integration is good. In some of them is not fully integrated in the development lifecycle, and also good practices regarding continuous integration are not propagated across those code bases, because since those are different and we are using different things, sometimes it's not easy to promote that standardization. Continuous delivery. Since there is some delay regarding the feedback that we receive when components are deployed regarding the impacts that we have in the Feedzai stack as a whole, imagine that you deploy a single component, but since we have some kind of dependencies between the components, imagine that there is something that it basically gets broke the stack as a whole when you put the components together. You only receive feedback regarding that once you try to do the integration, so it's not in the developer flow. Also, there is some lack of confidence because it's difficult to test against representative environments, because since there is a segregation between the development and the operational part where we actually deploy in our cloud and the thing is not completely integrated, it's difficult to have those representative environments for us to test against. Regarding continuous deployment, new features sometimes might take months in order to be adopted on existing clients because, as I said, the flow is not completely integrated, and once we have some hot fix or some new feature that is deployed on a component, we don't have an automated way in order to roll out that update to all the different clients that we have, for example. One thing that also is very important is that since also there is the difference between the development and the operations team, for example, stuff as blue-green deployments, version migration, how third-party components are updated, those things are normally automated by the operations team, and normally the operational team does not have the same knowledge as the development team has. So there is some kind of mismatch here that would be better if we have the things more integrated. Regarding testing, we have too much testing done on higher layers of the testing pyramid, and sometimes the tests cover too many scenarios and different environment configurations. That is something that we are also should try to fight against. And finally, regarding developer experience, practices, pipelines, tooling is very different from team to team, okay, because there is no standardization. So sometimes the people might say, if I move to a different team, it might sound like I'm going to a different company, things like that, okay, because the set of tools and the processes are quite different. And also developers want to work with modern processes and tooling. And this also impacts with the way that we are able to maintain our people. So it's important for us to move along and adapt those more modern ways of working and those new technologies. So what were the chapter focus that we identified here? Basically, there were 3 chapter focus that we identified while starting to bootstrap this initiative. One was on quality engineering side, where we tried to address things such as pipelines, test automation standardization, quality gates, developer experience, and dashboard and metrics. The main focus here is continuous integration, okay? So the fact that the developer, someone is able to write a merge request, write some code change, promote that code change into CI, and have feedback and have an automatic feedback regarding the changes. And the changes, if are okay, they will be automatically propagated across the complete flow. Then there is the development side, the development chapter. And here we have to deal with things such as containerization, how we break some of the products that we have, some of the products that are monoliths and that are not easily breakable in small pieces. Extensibility and upgradability. How can we guarantee a good upgradability path for our clients? Observability, that is something that we'll talk a little bit in the end of presentation, but is a must in today DevOps CI/CD. Feature flags, self-serviceability. This is more focused on continuous delivery. And finally, the continuous deployment, that is more focused on the infrastructure part, managed services, provisioning, orchestration and environments, security and hardening. Okay. In this particular presentation, we'll focus only on the quality engineering. Okay. So we'll be a little bit around those topics that I present early. And basically, I am trying to show to you what we are changing on the way that we do stuff. Okay. So first of all, let's start with a small warning. Okay. This is a work in progress. We are in fact doing a lot of those changes. So some of the things that I might be showing to you might not be a reality in, for example, 6 months or 9 months from on, because this is something that we are working on. And while we are working in a transformation project that is so big, you have to do a lot of discovery while you are doing it, because you are not able to plan ahead and just say, okay, will be my, what is the end goal, but you are not able to understand from the beginning all what we will do in order to reach there. So there are a lot of things that we are still trying to understand what the best way in order to approach. But we already have some things that we are able to showcase to you. Okay. So first of all, one of the things that we started by doing was refactoring all our CI/CD tooling. In fact, the CI/CD tooling is almost the same that we are using previously. So we use Jenkins, we use Nexus, we use Arbor for storing Docker images, SonarQube for static code analysis, Black Duck for software composability analysis. But one thing that we are doing is trying to move all those tools in order to Kubernetes, because in order for us to use those things in a CI/CD in the new CI/CD world where everything should be as code, we are moving those tools into Kubernetes, and we are forcing that everything should be in configuration as code. For example, nowadays we have many issues while managing, for example, Jenkins, because, for example, we might try to move some version to some plugin to new versions, etc. And since everything is managed by hand, you have a user interface and you perform some changes. That is good because it's lightweight. You are able to just change things and okay, you are ready to go. But on the other hand, you don't have like a sense of what is the current state of your Jenkins configuration. If there is some issue with your machine that stores your Jenkins, what will happen to you need to have backups and etc. But if you have something that you are able to store as a configuration as code, you are able to know at different life cycles of development, how was the configuration that time, what were the set of plugins that we are using, the versions from the plugins. You are even able to test how to migrate between different versions very quickly, because you might have an environment that you simply spin off a new environment and you understand if everything was good. And if that was good, okay, you promote that into production, something that we don't have currently, okay? Another thing that we are promoting is the usage of standard environments, both for testing and for production, okay? This is an example of from what we have before, where you might see on your left, there is local development and CI testing development, where, for example, we are using Docker or Docker Compose in order to mount the environments that we need to use in order to test against, okay? So basically we use Docker and Docker Compose, and in some way you get an environment that enable you to test against. What is the problem on this approach? Basically, our way of deploying is completely different, because what happens is that our cloud engineers pick the set of artifacts that we produce on different products, on different components, okay? And then they pick those artifacts and they roll out on AWS machines that compose the product as a whole. But as you see, those are two completely separated ways and different ways of testing the product, deploying the product, etc. So what we aim to do is to basically also use Kubernetes as a way to standardize the approaches. Imagine for local environments, you might simply have Kubernetes in your local machine, bootstrap an environment. For example, with Kubernetes, you might simply point to a Kubernetes cluster and launch the environment there. This is very good because you don't have, for example, to have a machine that have heavy configurations in terms of memory, RAM, CPU, memory, etc. Also on CI, we use the same type of environment. And then on our cloud environments, for example, staging and production, we might even use the same Kubernetes definition, okay? Because you only have one single definition for the product. The complete stack. The only difference will be in terms of sizing and scalability, because once you are in production, you might have a different sizing and configuration for the product. Once you are testing in CI or in local, you don't need to have that sizing and that scalability for what you are using. Shared CI/CD pipelines, as I discussed earlier in the problems that I showcased to you. All the different teams and different components use different pipelines and ways to do CI in their development process. So what we tried to do was create a set of pipelines as code that will support the CI/CD process, okay? Not only the continuous integration, but also the deployment part, okay? The premise here is that pipelines will be developed and maintained by the whole team. Of course, that there are persons that are more likely to understand how the pipelines need to be configured and the different stages that should have, and etc. But what we are trying to say is that everyone is able to contribute to that code base that define the pipelines, because it's something that is open and it's not closed in a silo from a given team, okay? It's open for everyone to contribute, and all the different code bases in Feedzai should use those pipelines, okay? We have, as I said, the same pipelines are used for libraries, components, distros, or flavors. We'll talk a little bit about what are those libraries, components, distros, and flavors in now, because basically we created 4 separated concepts regarding what should be a repository at Feedzai. Okay, so you might have a library that is simple. It's a library that it's not a service that you are able to deploy. So it's only an auxiliary library that you need to create by some reason. You have the component, okay, that is a component that is like a standalone service that is able to be deployed. So For example, I showed to you the examples from Pulse, from Case Manager, Genome. Those are actually components that we are able to deploy, okay, and that our clients use. Then we have the distros. Basically, a distro is a composition of a Feedzai tech stack, okay? And the Feedzai tech stack have different things: third-party services, databases, messaging services, etc. The Feedzai components, okay, the ones that are deployed, that are built at Feedzai, and the Feedzai test strategy. That is basically, for example, if you try to imagine that we have a client that wants to do transaction fraud for cards, for example. This is like there is a fraud strategy in order to deal with card transactions. Imagine that you are trying to do transfers. Imagine that you want to transfer money to someone. There is a separated fraud strategy in order to deal with that specific use case. Okay, so we need to combine all this together, and this represents a baseline that we deliver for a given client. Then there might be some clients that might need some specific changes and some custom changes based on their needs, and for those we called the flavors. Okay, and what type of things we try to validate on those different repositories, if we might call it so, to simplify. For example, once we are trying to, if you are in a library, imagine that we are working in a component, okay, we have an integration pipeline, and in an integration pipeline, the idea is like a developer is working on a feature, and the developer wants to put something into a branch that, and the developer ends the work in that feature. In order to validate that, we try to ensure that the developer, we try to guarantee that we compile the code, that we run linters. Basic linters tries to understand if there is something on our code that's regarding the check style of the code, if everything is ready, if everything is good, regarding the check style, the way that the code is written, try to find some bugs with static analysis, etc. The unit test part and the integration test part. Okay, if that is okay, we try to we allow the developer to merge the code into the develop branch. Okay, once the code is in the develop branch in a sync way, we will run some set of different validations that, for example, might be check if the Docker image from the component has vulnerabilities, do software composability analysis, that is understanding if the libraries that you are using have some kind of CVE, some kind of failure from a security standpoint, some kind of non-security issue, static application security analysis, dynamic application security testing, and the end-to-end tests that try to understand, for example, to cover some user flows, focus on the API, focus on the UI. Since those tests normally take more time to run, we want the developer to be able to continue to do his work and continue to work on new features. So the code enters in the develop branch, and then we will try in a sync way, try to promote that to the main branch. Okay, if we are okay to promote that commit because the commit entered automatically in the develop branch, and we want to promote that to main, if everything is okay, we promote to main. And if the tests pass, it means that we are okay to do a release in the main branch. Okay, this release in the main branch then might lead to a bump of the version that will happen on the distro. Okay, on the distro, we will do other set of tests that are more focused, for example, on the fraud strategy. Why? Because, for example, as we explained to you before, the components are standalone components. They are only software. You need to put the fraud strategy on top, okay, for you to be able to, for example, have rules, to have machine learning modules, to have an API schema that you need for the payment type that you are trying to process. So in order to, and we only have that on the distro part, because previously it was just a software component. So on the distro, we run those type of tests, for example, major user journeys, focus on the fraud strategy. Since we already have a definition of what the environment should be, we might run performance tests, resilience, we might do migration. For example, imagine that we have to add a new rule, or that we have to change a field from the API, and we might do migration testing in order to understand if everything goes okay. And then finally, we have the flavors. That is when we have a client that we put the things in actually production, staging, and production. Okay, but there also might be clients that simply use the distro as is because they don't need any additional change. If they need some change, we create then the flavor based on the distro, and we do the changes there. But as I said, everything is integrated. And for example, if a bump of a release on the main branch will break the distro, okay, we already know that happened, and the developer is able to fix that straight away, and the code is not even an actual release is made there. Okay, so basically everything is integrated, and previously this was not happening, and with this strategy we are able to validate the things completely in integration. Another thing that was very important for us to do is to focus our test against representative environments. The Feedzai main use cases, as we already talked a little bit about the third-party technology that we use. Here, for example, we have Spark, Elasticsearch, Postgres, Hadoop. Then we have the things that we build, Pulse Case Manager inside Genome. And then we have the part that is the Feedzai solution, that is the risk strategy, where we basically pick the set of components that we need, and we build a use case for our clients, okay? One of the things that, for example, we are not doing previously was using the configurations that we have available, the fraud strategy from Feedzai solution, the risk strategy defined on Feedzai solution, in order to test against the underlying components. Because, for example, imagine that you have some kind of feature that you need to test on Pulse, and that feature is very specific from Pulse. If you want to fail fast, you want to understand that something is wrong on the Pulse test itself, okay? So, and you don't want to span the different test cases across all the different set of solutions that we have. So if you push those test backs and if you use a configuration that is representative on the component itself, it will allow you to understand it will allow you to fail fast and test those common configurations, that the more common configurations from your product previously, instead of just waiting for the tests to run when they go a little bit right on the CI/CD pipelines. Okay. Another thing that we find quite funny, but it was also important for us to discuss. It's the standardization regarding test level concepts. This was an idea. I just put here 5 different type of test levels that we have at Feedzai. But initially, there was big confusion regarding what different test levels are, and basically we then try to come to a common ground also for those test levels. For example, for unit tests, we said that okay, unit tests test a class or a module in isolation. Okay, so you have a module and you are doing some tests in order to understand if the test functions, the class functions, are okay. Integration tests, it's what we do when we have multiple modules and we want to test those modules once against the others. One thing that we do, and we decided that it was not the correct thing to do, was, for example, bootstrap Docker containers in order to test a given model against. Okay, that is not, in our opinion, something very good. And for example, we base this definition with the definition from Martin Fowler, and basically integration tests should be isolated in the modules, and you should only run tests against a mock, because if you need to bootstrap a given service, you need to have that service running, or you need to bootstrap it in the scope of your pipeline. That is not something that we should do. Then the contract test. So we might want to test a specific model against a service from Feedzai, and that should be represented by a contract, and we test against that contract. Once again, we should not depend on having the service running in order to test against it. Then the end-to-end API test. So when we want to run a test against the API from a running system. And finally, the end-to-end UI test when we want to run a UI test against the running system. One thing that we also do was creating an engineering handbook that aims to keep all these discussions and all those concepts that we decide. And then when new people enter to the company, the person is able to see the handbook and try to understand what are the concepts and what are the common language that the persons use at the company. And this do not only cover the testing parts, it's for everything, for CI/CD, for the pipelines, for engineering practices, etc. Everything. The idea is for us to keep all this in the handbook and use it as a way for the persons that enter the company to be able to easily understand the company flow. Another thing that was very important for us was looking into our testing pyramids across different products and try to rebalance the testing pyramid. Some examples. In one product, we have in one component, we have more than 20,000 unit tests, and we were able to reduce the compile time from 2 hours to 30 minutes. Okay, so those are things that it's not what we are trying to say here. It's not enough for us to have CI/CD if our CI/CD takes a lot of time. Because if our CI/CD, if our tests take a lot of time, it means that also you need a lot of time in order to promote the features to the clients, in order to imagine that you want to fix a given problem that you found, and you are not able to ship it to the client because you have a very big pipeline with stages that take very long due to the tests. So this type of exercises is very important. So here we are able to have a big decrease in the time that the tests were taking. For example, on front-end integration, one thing that we did was replace a big portion of our UI tests that were written in Selenium by UI integration tests written, in this case, with Cypress. The thing here was not about Selenium and Cypress, was about the Selenium tests that were testing way too much. For example, we are testing the UI components. Our UI components react to a given set of changes, and we are not testing those things in the integration test layer, which is something that it's much more useful for us to do. For example, one of the things that is advocated here is the testing trophy. That is something that we also have to deal at Feedzai, because, for example, imagine our UI is made by components that come from a library called UIKit, okay? So basically, these developers only pick the components from UIKit, go to the main products, and just put the things in place, and etc. for us to have the user interface. So that the tests for those components are already on the UIKit integration test part. So, for example, what we want to try to test on the product, on the components itself, we want to test that the different components works okay in integration with the others. So, if you have a given page, you want to ensure that if you put the button here, the label there, etc., if they have interactions, those interactions work correctly. Okay. But those are not things that you should also test on the end-to-end test layer, because on the end-to-end test layer, you should try to cover what are the main user flows, okay? So this takes us to the next slide regarding front-end end-to-end test, where we said that end-to-end test should only cover the main user flow scenarios that are impactful in the product lifecycle. Imagine if you have a given checkbox and if you have some kind of error message that did not appear by some reason, it's not something that is really, depends of course of the nature of the product, but it's something that did not impact and probably you want to release because that is not something very impactful. That is a test that should be, for example, on the component that should show that given message and that is not showing. So if you want to change that, for example, you go to the UI library and you add that test, okay. On the end-to-end test that you have on your component, you want to cover the main user flows. What are the actions that the user normally does when interacting with our product? And so basically, we will try to aim our focus on that. So end-to-end test should cover the main user flows, and all the rest should be placed on the test at lower layers of the testing pyramid. Other thing, testing tools and standardization. With this initiative, we are also trying to promote a common quality tech stack for the organization. And the main idea is to ensure that both quality engineers and developers can contribute both in the definition of testing frameworks, automated test case creation, etc. For example, here we have a layer of tests. For example, the back engineers might contribute the unit tests, to the integration tests, end-to-end tests at the API level. Front-end engineers might contribute to unit integration tests related with the front-end part, but also contribute to the end-to-end tests at the UI. And the software engineers in test can be able to cover from the integration to the end-to-end UI part. And what we try to do here is try to set a common quality tech stack, as I said, that tries to use tools that are aimed for both for the different profiles. For example, if you are writing for a developer, a backend developer, it normally it probably knows how to work with UUnit, Mockito. Rest Assured is a tool for API testing that is also well known. And for example, if you're someone from front end, it will be able to use, for example, Jest for front end test, Cypress for the integration. But if you look into a software engineering test, a quality engineer, he should be able to cover, for example, Cypress for the UI tests or the integration, and for example, be able to use Rest Assured for the end-to-end API test. So here we are able to use the same set of tools for different profiles in our organization, and that promotes reuse and also being able to have persons that are able to help you even if you have troubles with the tool that you are using. You are able to have more persons helping you instead of using, for example, a framework that might be only used for quality engineers. For example, if we go to Selenium, and that was one of the decisions that we made in order, for example, to change our tests from Selenium, start changing our tests from Selenium to Cypress, because in that way we could have the developers helping us in the writing of the testing framework and also the test case creation. Here we have an article from Medium. If you want to search a little bit on Feedzai Medium, from zero test to hero, that talks a little bit of this transformation, how we bootstrap the collaboration in order for us to start using Cypress among both front-end engineers, quality engineers, and on different layers, both integration and the UI end-to-end test part. Another thing that we started to do was the containerization of the end-to-end tests. So basically, we have tests that we are, for example, written with JUnit and Rest Assured, and tests with Cypress IO. and we pack those tests in a bundle, and we create a Docker image with those. Why is this important for us? This was important for us because, first, it's more user-friendly for Kubernetes to run the tests if those tests are in a container. And we simply put the container alongside with the environment, and we run the tests against the given environment. Other thing is that we might even have, for example, persons that are not using the things that we are built for CI/CD right now, because not all the projects that we have will able to adopt this vision. Some of them will only able to adopt this vision some years ago. So, but by creating a bundle with the tests, everyone might simply pick the bundle and run the tests against a given environment. Doesn't matter what the environment has. In fact, it matters because you need to have an environment that suits the tests that we are running against. But you might have different teams that bundles their tests, and you don't even need any kind of dependency. You only need to provide the set of endpoints, and then the tests simply run against the endpoints that you are providing without you needing to installing anything on your side. And this fulfills also a vision that we have at Feedzai, because imagine, for example, as I showed to you before, we have the distros and then we have the flavors. A flavor might be an extension of the distro, okay? So you won't be able to run, for example, tests that you have in a distro against the flavor. You don't want to go to the flavor repository and copy all the tests there. No, you simply have a bundle and you say, okay, with some feature flag for the tests, I want to run a test that covered this, that, and that scenario. And those tests then are able to simply run against a given flavor. The same might happen, for example, for the distro. For example, it's not common for Feedzai distros to have machine learning modules, because machine learning modules are something that is very intrinsic from the different clients, because we need data sets, etc., in order to perform those analysis and create good modules. But imagine that we might want to have a testing pulse that guarantees that we are able to train a model in a distro. And if we have the testing pulse, we might simply pick it and running against a given distro, because imagine that there was some kind of scenario, some kind of different configuration for the machine learning models that you want to test. And if you have it on the test bundle from the component, you are able to run it on the distro itself, for example. Other thing that is very important is the question of shifting left on the test types. So there are some type of tests that we normally run in an ad hoc way, okay? And now we are able to cover those tests in the pipelines. Some examples: the software composability analysis, as I said, is trying to understand if you have vulnerabilities in the libraries from your code, or if you have licenses that you cannot use in the product. Perform dynamic application security testing is something that normally the security engineers do in an ad hoc way against the different environments. But now we are able to pick those tests and put it on the pipeline, on the CI/CD pipeline, and also performance testing. Because if now we have an environment that is representative, and if you are even able to configure an environment and put it with the same sizing and with the same specs as a production environment, we are able to run easily performance tests against that environment that is representative and have the same configuration from a production one. Okay. Other thing that tries to end a little bit the gap. So the gap, no, but the different stages. We already talk on the tools. So the tools being in Kubernetes. Everything is configuration as code. The pipelines are common for everyone. We want to change the way we want to have representative environments that match our client needs and the configurations from our clients. We want to refactor the way that we do the tests. and we want to add also some new type of tests that normally do in an ad hoc way to the pipelines, okay? But then you need to ensure that your quality process is not deteriorating and your quality engineering practices are not deteriorating along the time. So, for example, for that, we created a wrapper against using Jenkins that basically, after each pipeline, the test results are persist. By using Jenkins, we are able to be framework agnostic, because you might be using, for example, Cypress, JUnit, you might be using Python, doesn't matter. You only have to send the test results to Jenkins, and in the end of the test execution, you simply pick those test results, the results from the build, the set of tests that you run, etc., and you are able to persist those metrics in order to understand how is your quality along the time, and in order to ensure that you are not deteriorating the product quality. What are some metrics that we are covering? For example, the average pipeline time, for us to try to understand if the pipeline is trying to starting to spend a lot of time. What is the normal stage duration from the pipeline? Because you might have some stages that start taking more during along the time. How is your test level distribution, trying to ensure if you are matching the good how a testing pyramid should be? How is the average time that you take by test level, for you to understand, for example, if your unit tests are taking too long, or if your UI tests are taking much more than the unit tests, etc. Those type of analysis. How is the pipeline stability, and how stable are your tests? Imagine that you have a lot of tests that are failing in your pipelines. That means that you will not be able to deploy during your CI/CD pipeline, and so the tests should be stable, and we need to understand if the tests are stable or not, if we have flaky tests. So those are common quality metrics that we try to keep. This is an example of some dashboards that we build in order to track those metrics against different components from our tech stack. And as I said, this is simply an opt-in in the pipelines, and we collect the metrics for the different components. Finally, one thing that it's not a process or something that we change, but it's something that I felt that was important for us to talk a little bit about, is the observability and how it is important on quality engineering practices, okay? Because once you do some kind of trade-offs, previously, for example, in our product, we are saying that we have too many tests, okay? And those tests are covering a lot of stuff. But we are also saying that those tests will not allow us in order to have fast pipelines, in order to deploy fast to our clients, okay? It's not possible to have that. So, but ideally, in an ideal world, we might have those tests if we have time to run those and etc. But for example, if we imagine once America tried to go to the moon, ideally they would try to test and go to the moon if they have a moon some meters away from Earth, but that is not possible. And the same thing happens in those software development life cycles. If you want to left some things fall, for example, if we want to not cover so much thing on the end-to-end tests, if we want to bring shiftings left, etc., probably there are things that we also need to understand how the product is behaving when the product is deployed, when the product is being used by the clients. So observability allow us to do that, and allow us to take metrics, trace logs. We have tests, traces, metrics, logs in the product, and this will allow us to understand how the client is using our product. And this is something that is very useful for us to try to understand how how the stack is behaving, how the product is in production, and etc. So it's something that it's not something that we already covered. It's not something that we already did from a quality standpoint, because this is also that something that is being included on the products, the observability part. We already have a lot of those things, the logs, the traces, and the metrics, but we are also trying to standardize. But it's something that I would like to explore in the future. All quality engineer might be applied to this observability part. And finally, I think that the main message here is like we are always trying to, and as much as we can, trying to embrace things among the team. So as we said, there is DevOps. The DevOps part should be merged. We want software engineers in test or quality engineers to write tests, but we also want the developers, the front-end developers, the back-end developers to write tests. We want the whole team to understand how our pipelines are mounted. We want the infrastructure to be something that everyone can contribute. So as long as we adopt this mindset, quality engineers should be a quality engineer should be a domain expert in the team for those things, for example, pipelines, for test automation, for the how to shift left, how to ensure that the pipelines are not taking many time during the development life cycle, etc. But the main thing is the whole team needs to be responsible by this quality process. And if that did not happen, the whole mission and the whole purpose of the initiative fail. So this is a final message that I want to leave to you, and I think that on my side it was everything, and I am able to answer some questions regarding the topics that we were discussing.